Okay, on to question 6, which I think you guys would have recognised was in our trig test at the end of last term. And I made, when I made it for you guys, I forgot to include this part here in the test I gave you guys, which is crucial to solving part 3, which is the part that you guys did rate the highest as not being sure what to do. But I'll go through the whole thing again, as it kind of is all linked up anyway. So the first thing to do is read the question really carefully. The metal plate, it says, is made by fixing those two pieces together. So this is the metal plate. So all of around here, down here, over here, and back to there, that's the metal plate. So when it asks you for the perimeter, it's asking for that stuff that I've just drawn in pink. So let's start off with the easy part. So first of all, you can see on that perimeter is R plus R. So you've got that side there and that side there. What you need is the curved edge BC. So that's this whole sector here, which has a length 2R and it has an angle of alpha. So our rule for the arc length is that it's the radius times the angle. And in this case here, the radius is 2R. So we're going to add on 2R times alpha. And be careful that you use the alpha symbol and not the theta symbol. I know that the formula says it's theta, but we're doing things in terms of alpha and r's. That's what we've been asked to do. So the last thing we need now, we've got the R there, we've got the arc length there, is we need all of this perimeter here. And to get all of that perimeter there, there's two ways that you can do it. And I'm going to do one way, but you're welcome to do another way, is I'm going to say that's the same as if I took the whole circumference of the circle, and the whole circumference of the circle would be 2 pi r. So that's 2 pi r. And I'm going to take away this small part here that I don't want. So that one left over with is just the outside part there. So that small part there would be the same as alpha times r. So alpha, and r, like that. And if I go through and tally that up, first of all I'm going to get 2r from the first part there. I'm going to get 2r alpha minus alpha r. So they're the same thing, r alpha, alpha r, whatever. That's going to leave me with 1 r alpha, or alpha r, and that's going to leave me with that 2 pi r as well. Okay, and on to part 2. So we have to do the same sort of thing, but this time work out the area. So again, we're going to have to do the area of the shaded part, and in the area of the white part, that doesn't include the smaller sector here. So if I just put on a little blue line there, that's the smaller sector. Okay, so let's do this in a few parts. So first of all, let's do the area of the shaded part, which we know the formula for area is half r squared theta. And what's really important when we work out the area of that shaded part there is that the r in this case is 2r, and we need to make sure we put that in brackets before we square it. So all of 2r is squared, and then our theta this time is actually our alpha. So when we expand that out, what's going to happen is we're going to get 2r times 2r, which is 4r squared, and then we're going to half that, so we're going to end up with 2r squared alpha. Okay, we also need to find out the area of the small part of the grey part, the small part here, so we can take it away from the whole area of a circle to get just the white part. So when we do that, it's actually exactly what that looks like. So it's half r squared, except we're going to use alpha, not theta. So that's the small part. And we're going to take that away from the area of the whole circle. So the area of the whole circle is going to be pi r squared. That's just our normal formula for the area of a circle. And then we're going to take away from that what we've just worked out here, which is the area of the small grey sector. So we're going to take away half r squared alpha. Cool. So to put that all together, this part here is the area in white, and this part here is the whole area in grey. So to get the whole area, we're just going to add those two together. So pi r squared minus half r squared alpha plus 2r squared alpha. And then all we're going to do for our last step is just tidy that up. So if we look at this here, we can see that we've got minus half r squared theta, and we've got 2r squared theta. So they're like terms. When we add that together, we're going to get 1.5 or 3 over 2. So that stays as pi r squared plus 3 over 2 r squared alpha. Okay, and for the last part, it's actually easier than obviously when you thought it was in the original test, because you actually have this piece of information now that tells you that the area of the shaded part is the same as the area of the unshaded part. So if we just take the area of the shaded part again, so the area of the shaded part, if you remember, was half 2r in brackets squared times alpha. We know that that's got to be the same as the area of just the white part, which, if you remember, was the same as pi r squared, because that's the area of the whole circle, minus the area of the small grey sector, which is half r squared alpha. So that's the first part there, setting up those two equations, equating them because you know that the areas of those two parts are equal in size. The next part is just to rearrange it, and you want to make alpha the subject. So have alpha on the left-hand side and everything else on the right-hand side. So I'm just going to expand this out again to get to r squared alpha to tie it up. Remember, again, that was by doing 2r times 2r, so getting 4r squared, and then halving it to get 2r squared theta. And then I'll just rewrite the other side out again. Cool. So what we can do is, because I'm trying to get alphas together, I'm going to add this to this side. Or I'm going to add half r squared alpha to both sides, technically. So what I'm going to get over here is 2.5, which is the same as 5 over 2. R squared theta, that's going to be the same as pi r squared. And then what I want to do is get alpha here by itself. So I'm going to divide through by 5 over 2 r squared on this side here. So alpha is going to be the same as, I'm just going to move up here, pi r squared all over 5 over 2 r squared. That's alpha equals that. So when we do some dividing through, we can divide through by r squared, and that's going to leave us with pi over 5 over 2. Now, that's not a real fraction. So you have to remind yourself that when you divide by a fraction, so dividing by 5 over 2 is the same as multiplying by its reciprocal. So that's the same as pi times 2/5. So the answer then is 2 pi over 5.